For decades, America was told that true performance came from metal, heritage, and mechanical genius. A great executive car needed a legendary badge, a perfectly tuned rear differential, a gasoline engine with drama in its exhaust note, and a chassis shaped by generations of European racing knowledge. That was the old religion. Porsche Panamera, Taycan Cross Turismo, and the entire German Grand Touring empire were built on that belief. But the GT7 coming out of China challenges something much deeper than horsepower. It suggests that the future of vehicle control may no longer belong to mechanics. It may belong to computation. When a 2.5-ton electric Grand Tourer can read the road, predict body motion, distribute torque through 3 motors, and adjust suspension, before the driver even feels the weight shift, the old hierarchy starts to crack. This is not about China building a nicer luxury car. This is about software beginning to control physics faster than mechanical hardware can react. That is why the GT7 matters. It is not attacking Porsche from the traditional angle. It is not trying to win by sounding better, feeling more nostalgic, or carrying a more emotional badge. It is attacking from the blind side: centralized computing, predictive chassis control, high-resolution perception, and battery thermal management. In the old world, a car reacted after physics happened. The body leaned, the tires loaded, the suspension compressed. Then the mechanical system fought to restore balance. In the new world, the car tries to calculate that movement before it fully arrives. This is the industrial threat hidden underneath the luxury bodywork. For years, Europe protected the top of the market with craftsmanship, tuning experience, and brand authority. Detroit watched that battle from a distance, because Porsche was never supposed to be the direct enemy of the Ford F-150 or Chevrolet Silverado. But digital chassis technology changes the battlefield. The same logic that can stabilize a heavy Grand Tourer through a fast corner can one day stabilize a loaded pickup on a Colorado grade, a family SUV on icy Michigan pavement, or an electric truck crossing Texas at highway speed. Once the control layer moves from steel to silicon, the competition is no longer just about who builds the strongest machine. It becomes about who owns the fastest decision-making system inside the machine. The core of the GT7 story is not the shape of the body. It is not even the number of motors. The real story sits underneath the skin, inside the control logic. Traditional performance cars, even brilliant ones, still depend on a mechanical chain of reaction. The driver turns the wheel. The front tires load up. The body begins to roll. Hydraulic valves move. Dampers compress. Anti-roll bars twist. Separate control modules exchange information, and only then does the vehicle begin correcting itself. In a Porsche Panamera, that process has been refined to an extraordinary level. But it is still a reaction. It is still physics moving first and hardware trying to catch up. The GT7 attacks that delay directly. Its XMC digital chassis is built around a different philosophy. The car should not wait for weight transfer to become a problem. It should predict the problem before the mass fully moves. That distinction matters because this is not a light sports car. This is a large electric Grand Tourer weighing roughly 2.5 tons. At that weight, every corner becomes a negotiation with inertia. Once the mass starts moving outward, the tires must fight a huge lateral load. In a conventional chassis, the system responds after the load has already arrived. In a predictive digital chassis, the system starts preparing before the driver feels the full movement. That is where centralized computing becomes dangerous to the old order. Instead of multiple systems working like separate departments inside a company, the GT7 treats propulsion, suspension, braking, steering feedback, and body control as one connected organism. The digital brain calculates pitch, roll, and yaw repeatedly in real time. Then it can redistribute torque across 3 independent electric motors, adjust damping force through active air suspension, and shape the vehicle's attitude before the chassis fully settles into the corner. It is not simply correcting the car. It is preloading the car for the next physical event. This is why the comparison with old mechanical prestige becomes uncomfortable. A limited slip differential is a masterpiece of mechanical engineering, but it is still limited by gears, clutches, friction, and response time. A hydraulic suspension system can be beautifully tuned, but fluid still needs to move. An anti-roll bar can resist body roll, but it cannot think ahead. Digital torque vectoring changes the equation because electric motors can alter output almost instantly. If the rear outside wheel needs more torque, the system does not wait for a mechanical part to transfer force through a shaft. It sends a command. If the car begins to understeer, the software can alter torque, damping, and body attitude as a coordinated move. For the American market, this is not just a luxury car curiosity. The same control logic has direct implications for pickups, large SUVs, and electric trucks. Imagine towing 8,000 pounds through a long Colorado descent. Imagine a family SUV crossing black ice in Michigan. Imagine an EV truck changing lanes at highway speed in Texas with a heavy battery pack under the floor. In those moments, stability is not about romance. It is about milliseconds. It is about whether the vehicle can understand load, grip, speed, and body movement fast enough to keep the driver out of trouble. That is why GT7 matters beyond Porsche. It shows a future where the most important chassis component may no longer be a mechanical part at all. It may be the decision loop. The GT7 does not treat luxury as decoration. That is the second warning hidden inside this car. In the old executive formula, luxury was easy to recognize from the outside. Leather quality, metal switches, perfect stitching, a quiet door close, and a badge that told the world the owner had arrived. Those things still matter, but they are no longer enough. In a digital grand tourer, luxury becomes an engineering problem. It becomes the ability to isolate the human body from vibration, noise, pressure, heat, fatigue, and information overload while the vehicle moves at highway speed. That is why the cabin architecture matters. The GT7 is described less like a traditional interior and more like a controlled acoustic chamber. Double-layer laminated glass reduces wind and traffic noise before it reaches the passengers. Sound-absorbing materials inside the aluminum structure attack low-frequency road drone before it travels through the floor. This is not just comfort. It is physics management. Noise is vibration. Vibration is energy. And if an automaker can control unwanted energy inside the cabin, it can make a heavy EV feel calmer, more expensive, and more precise than the badge on the hood would suggest. The seats follow the same logic. They are not simply soft chairs wrapped in expensive material. They are biomechanical support systems designed to distribute body weight, reduce pressure points, and keep occupants stable over long-distance travel. That matters for the American use case. A luxury EV crossing California, Texas, or the Midwest is not judged only during a 10-minute test drive. It is judged after 3 hours of road noise, bad pavement, heat, glare, and fatigue. If the car can reduce those physical penalties, it changes how people define premium travel. Then comes the cockpit, and this is where Huawei's role becomes impossible to ignore. The central screen is not important because it is large. It is important because it represents a different operating philosophy. Traditional automotive infotainment often feels like software trapped inside a machine designed by hardware companies. Harmony OS flips that relationship. The vehicle becomes a computing device with wheels, using fast processors, smooth graphics, real-time mapping, climate prediction, sensor data, and cabin controls as part of one digital environment. This matters because the dashboard is no longer just where the driver changes music or checks navigation. It becomes the interface between the human and the vehicle's decision-making system. The same digital layer that manages entertainment can also display road perception, energy status, charging logic, cabin conditions, and assisted driving information. In other words, luxury becomes data made invisible. The best system is not the one that shouts at the driver. It is the one that quietly removes friction before the driver notices it. The next layer of the GT7 is where the argument becomes even more uncomfortable for the old automotive world. A digital chassis is powerful only if the car understands what is coming. If the vehicle can only react to what the tires already feel, then it is still trapped inside the old mechanical timeline. But if the vehicle can see the road before the tire touches it, then chassis control becomes something very different. It becomes prediction. That is why the 896-line LiDAR matters. This is not a decorative sensor placed on the roof to make the car look futuristic. It is part of the vehicle's physical nervous system. A conventional camera can recognize lanes, cars, pedestrians, and traffic lights, but a camera is still interpreting reflected light through a flat visual image. It can struggle with darkness, glare, heavy rain, fog, or strange road texture. LiDAR changes that relationship by building a three-dimensional map of space. It does not just ask, what does the road look like? It asks, where exactly is every surface in front of the car? In the GT7, that information does not stop at assisted driving. It feeds directly into the logic of the chassis. If the sensor detects a pothole, a shallow depression, a broken road joint, or a thermal crack in the asphalt ahead, the suspension can prepare before impact. The air suspension can adjust pressure. The dampers can change force. The body can be stabilized before the wheel reaches the disturbance. This is not comfort in the old sense. This is a car using perception to alter its physical behavior. For American buyers, this has a deeper meaning. Think about a luxury SUV hitting broken pavement outside Detroit in February. Think about a heavy EV crossing expansion joints on a Texas highway. Think about a pickup towing weight over uneven mountain asphalt in Colorado. Traditional suspension absorbs the road after the road attacks the vehicle. Predictive suspension tries to disarm the road before the attack arrives. That is the shift. The car is no longer just a machine moving through terrain. It becomes a machine negotiating with terrain in advance. Then comes the battery system, and this is where the GT7 moves from chassis warfare into energy warfare. The old EV debate often focuses on horsepower, 0 to 60 numbers, or range claims. But the deeper engineering bottleneck is heat. When huge current flows into a lithium-ion battery during ultra-fast charging, internal resistance creates thermal stress. If that heat cannot be removed quickly, the charging curve must slow down to protect the cells. That is why many EVs advertise impressive peak charging numbers, but cannot hold those numbers long enough to change the real travel experience. The GT7's 800-volt architecture and 6C charging capability are important because they attack that bottleneck directly. A 6C rate means the battery is theoretically accepting charge at 6 times its own capacity per hour. That is an extreme electrical event. To survive it, the pack cannot rely on ordinary bottom cooling plates alone. It needs a thermal structure that reaches deep into the cell arrangement, pulling heat away before chemistry becomes the limiting factor. In the GT7's case, the cooling matrix is described as being placed between cell rows, dramatically increasing the contact area for heat removal. The claimed result is the kind of number that changes consumer psychology. Roughly 1 kilometer of driving range recovered for every second connected to the right ultra-fast charger. Even if real-world conditions vary, the direction is clear. The goal is to remove the waiting penalty that has haunted EV adoption. In America, that matters because distance is cultural. Texas highways are long. Midwest winters punish efficiency. Rural charging gaps create anxiety. Families do not compare charging curves on a spreadsheet. They ask one simple question: will this machine slow down my life? That is why the GT7 is dangerous as a symbol. It connects the 3 domains that legacy automakers often treat separately: perception, chassis, and energy. The LiDAR sees the road. The chassis prepares the body. the battery system attacks downtime. When these systems are connected by fast computing, the vehicle no longer behaves like a collection of mechanical parts. It behaves like a coordinated platform. And that is the part Detroit and Europe cannot afford to misunderstand. This is why Porsche becomes a symbolic target. Not because Porsche is weak. The opposite is true. Porsche matters because it represents one of the highest expressions of the old performance order. The Panamera proved that a large executive car could still feel sharp, disciplined, and expensive. The Taycan Cross Turismo proved that Europe could translate part of that performance identity into the EV age. But the GT7 exposes a new vulnerability. If chassis feel can be generated through software, if torque can be distributed faster than a mechanical driveline can respond, if LiDAR can prepare suspension before the road impact arrives, if battery cooling can attack charging downtime at the chemical level, then the old advantage becomes less absolute. The warning for Detroit is indirect, but it is real. Today, this technology appears inside a luxury electric Grand Tourer aimed at Porsche. Tomorrow, the same logic can move into SUVs, pickups, and heavy American family vehicles. Ford, GM, and Ram do not have to build a Porsche rival to feel the pressure. They only have to compete in a market where customers begin expecting software to stabilize weight, sensors to read terrain, cabins to suppress fatigue, and charging systems to remove waiting time. That expectation will not stay in the luxury segment forever. Mechanics are not dead. That would be too simple. Steel, suspension geometry, tires, brakes, and structural engineering still matter. But mechanical supremacy is no longer protected by tradition alone. The new battlefield is the decision loop between sensor, chip, actuator, and battery. The company that controls that loop controls how the vehicle feels, reacts, charges, and protects its passengers. That is the industrial shift hidden behind the GT7. And that is why this car should not be dismissed as another Chinese EV headline. It is a signal. The old world believed performance came from mastering mechanical reaction. The new world is trying to win by predicting the reaction before it happens. If Europe and Detroit treat that as a gimmick, they may discover too late that the center of automotive power has already moved, from the machine itself to the intelligence controlling it.